Hello everyone and welcome back to the BioRT-HBV tutorial video series. This series group is going to teach you how to run a silicate weathering reaction in BioRT-HBV. Today we're going to be talking about running the model using the input files that we've already created together. Let's take a look at the file structure that I have set up here in order to run the model. In this folder, I have the BioRT executable file and two folders labeled input and output. If we go into the input folder, we can see that there's several more subfolders. Each of these represents a case that we can run in the BioRT-HBV software. If we go into this one that's titled Sleepers River Silicates, we see 8 files that we recognize from the last video. These are our input files. So we have a database, chemistry data, initial conditions, 2 precipitation chemistry files, parameter file for HBV light hydrology model, results file from HBV light, and soils data. Going back to the overarching directory, we've got this BioRT.exe here. So in order to actually run the model, we're going to right click and select Open in Terminal. In order to run the model, all you have to do is type in /BioRT.exe space, and then type in the name of the case you have put in the inputs folder. Make sure that you don't type this in incorrectly. So for instance, I'm just going to misspell this. This will give you an error message, which states that the program can't open the soils file, and that's because the overarching folder doesn't exist. So in order to run the model, just hit enter. You'll get some text. And if you have a successful run, the model will print the following text. HBV BioRT, Sleepers River Silicates, numerical experiment succeeded. It also states that the regular simulation, it also states that the HBV BioRT Sleepers River Silicates simulation started and succeeded, but we're specifically looking for the numerical experiment to have succeeded. Once your model has successfully run, go ahead and close the terminal window and navigate to the outputs folder. Here you'll see 2 new files. They are going to be named after the case name that you gave, the inputs folder, and the date. And one is also going to have the phrase num.exp, which stands for the numerical experiment. This file you want to double check first and then copy into a folder in order to analyze it using Python, R, or MATLAB. The first thing I'm going to do is open it with Notepad++, and I'm going to double check that all of the columns are filled with numbers and not NaN values. So that's my first check. The next thing I'm going to do is I'm going to go ahead and copy the file and open my directory where I will analyze the data. So here, I'll go ahead and drop it in. I will copy the name of the file. I'm going to open this in R. First thing you're going to want to do is clean up the file a little bit. I prefer to start by removing the second row of the file, which just contains the units for each column. I also like to make sure that the formatting for the date column is as a date format so that my program, my R's code can actually process it, and to make sure that all of the other columns are numeric format. Once I've done that, I can open up and view the file that's generated. So I have proton, calcium, silica for the snow, surface, upper zone, UZ, lower zone, LZ, and the river, which is the stream concentrations. I also have anorthite in the river. In addition, I have anorthite rates in several of these columns. So I have anorthite rates for upper zone and for the lower zone. I've also chosen to join the hydrology data to the results file in order to do concentration discharge analysis, etc. The first thing I'm going to take a look at is what are the reaction rates, the absolute values of the reaction rates in the upper zone and lower zone. And I'm seeing that in the lower zone, which is this dark green, after the first day, the reaction rates are changing through time, while in the upper zone, which is this light green, they remain constant at 0. And that has to do with how you've set up your reaction network and the different terms that you've chosen, which can affect the reaction rate. The second check that I'd like to do is to look at the concentrations of the solute of interest, which in this case would be calcium. And I'm going to look at it in the stream, upper zone, and lower zone. Here I'm seeing that the stream calcium concentrations are modeled in blue as this blue time series. The green represents the soil water calcium concentration, and I've plotted the groundwater concentrations of calcium as this sort of dark pink line. There are lots of other things that you can check or plot, including concentration discharge relationships, etc. But those are the two first things that I double check every time I do a run. That's it for this video on how to run the BioRT-HBV model for silicate weathering. In the next video, we're going to look at how to change the parameter values in the initial conditions and the other input files so that you can change different things like the rate constants or other parameters, and how those changes to the parameters will change the results in your output file.